Let's take a look at number 4 from the AP Chemistry 2025 FRQ. A scientist is investigating the properties of a mixture of methanol and formaldehyde. The scientist generates the following diagram to represent the mixture. For part A, it's asking us to identify the hybridization of the valence orbitals of the carbon atom in our formaldehyde, the H2CO. So if we take a look at the carbon atom, it has 1, 2, 3 domains. Because it has 3 domains, it is going to have a hybridization of sp2. So then sp2 is going to be our answer for part A. If we take a look at part B, it says, in the diagram provided, draw a single dashed line, and it emphasizes single, to represent a strong hydrogen bonding attraction between one CH3OH and one H2CO molecule in the mixture. So they set up a lot of potential combinations here, but there's really only one that is easy to represent without you drawing all the way across the diagram. So all of the oxygens that are here are going to have a partial negative charge because they're all participating in polar bonds. But it's only these oxygen-hydrogen bonds in the methanol that are going to be able to be partially attracted, that will be able to be attracted to the partially negative oxygens in the formaldehyde. So this is the easiest one that you can set up. This is going to be partially negative, that's going to be partially positive. This is partially negative, that's partially positive. This is going to be our attraction for our hydrogen bonding. All of these other ones are not going to make it work. Like these hydrogens here for the carbon-hydrogen bond, those are non-polar bonds. And so the hydrogens will not be partially positive, so they won't be attracted to the oxygen here, even though the oxygen's partially negative. Moving on to part C, it tells us the scientist plans to cool a gaseous mixture of the methanol and the formaldehyde to form a liquid mixture and finds data on the 2 compounds, and then they give us the table for the data. For part I, it says propose a temperature to which the mixture should be cooled such that methanol and the formaldehyde will both be liquids. So we want to think, well, what's the hottest temperature that we can have while both of them are remaining as liquids? Boiling point is going to tell us the hottest potentials. So comparing these 2 boiling points, the lower one is going to be 254 because anything above 254 will then force the formaldehyde to become a gas, and we want it to stay as a liquid. So this is going to be the maximum range. I would even say 253, just to be on the safe side, is the max Kelvin value that you should have. In terms of the minimum, we have to then look at the melting point. The melting point tells us, well, what's the temperature at which you can have something remain as a liquid or have a solid turn into a liquid. And then so we want the higher of these 2 values because on the lower end, it's going to be a solid. So the higher one is going to be 181. So that is then going to allow the methanol to melt and become a liquid, and it will also allow the formaldehyde to melt and become a liquid. And then the same reasoning that we had for the boiling point, you want it to be just a little bit above that just to be safe. So then this is the range that we're going to want for part I here. So any value between these, like you can just say like 200 Kelvin. 200 Kelvin is a temperature that will work, that'll keep both substances in a liquid state. For part II, it says the scientist analyzes the mixture after it is cooled and determines that 8.59 grams of the methanol liquid is present. Calculate the amount of thermal energy in kilojoules that was removed to condense the 8.59 grams of methanol with the molar mass at its boiling point. So if we look at the data table that's presented to us, they give us the enthalpy of vaporization, which is going to be the energy required in order to force the liquid to become a vapor, to become a gas. And then so it's then asking us, well, how much thermal energy was needed, how much thermal energy was removed in order to condense this. So because it's asking for units of kilojoules, that is very close to what they're already given us. So then now we just have to cancel out the units of moles. They give us a mass value and a molar mass, which then allows us to get to moles. So we should take the 8.59 grams, convert that into moles using the given molar mass. We then get 0.268 moles of the methanol. And then we just have to select the heat of vaporization of the methanol. So then we can just go one more step here and then even just have for every 1 mole of the heat of, or the enthalpy of vaporization, that is how many kilojoules we're going to end up with. And then we end up with this many kilojoules. So because it specifically said removed, that means that it's going to be a loss of energy. So then this would either be negative, or we would then just say, well, we removed 10.1 kilojoules from the 8.59 grams of the CH3OH.